Hello everybody, this is Mr. Bowman. So today we're going to be looking at how to graphically solve a system of linear equations. So this is relatively straightforward. Our goal now is to graph both of these two on the same line and figure out where or if they run into each other. It does have a note here that says you can also do no solution or infinitely many solutions. Those are our two special cases. So no solution would be if we get those parallel or inconsistent lines. Infinitely many is when we get those coincidental or lines that land on top of each other. So we'll see if we get either of those. So notice this one's ready to go. It's already in slope-intercept form. This one is in standard form. If you want to graph it from standard form, you're welcome to. Or if you want to solve it, which this one's pretty straightforward, it's one step to solve it into slope-intercept form, so we'll go ahead and do that. But we're going to do this one first. So I'm going to start at my y-intercept here at -1. And then I have a slope of -1/2. Remember, this negative just goes to the top, not both parts. So that means I'm going to go down 1, right 2. Okay. And then this is a regular equation, so we have a solid line here. And yours are going to line up a lot nicer. I forgot to print a graph on this, so I'm sketching this. But we'll make sure it works out. So here, I do want to add this 2x to both sides so that I can get this in slope-intercept form, and it looks like this. Okay, just add that over. So here we're going to start at 4 and have a slope of +2, so we're going to go up to right 1, and then we'll have a line that goes like this. Okay, so this appears to cross at -2, 1. Like I said, when you do it on Alex, yours are going to end up a lot nicer, but in the off chance that you are doing this on paper, I'm going to show you how to double check to make sure we did solve this correctly and are not slightly off based on our human error in our picture. So this appears to be at -2, 1, right? So what I'm going to do is I'm going to actually plug that into both of these here to make sure it works out nicely. So I have 1 equals -1/2 times -2 minus 1. And if we do that, by the way, I just plugged in -2 and 1, my x and y coordinates for x and y. So it does look like we do have an error here, so -1/2 times -2 is going to be 1 minus 1, so that's 1 equals 0, so that does not work. So that means we do have a bit of an error somewhere, but it's usually in that range, so try some around there and see if they work. Like I mentioned, on Alex, you're good to go. Yours are going to turn out really nicely. But I think I actually might be too high after I glance at this a little bit more. It might actually be supposed to be down here. So let's try that. And by the way, if you are doing this on Alex, you can feel free to stop the video at this point. You don't have to watch this part, since this is how to do it on paper. So that checks out. On the second one, you do the same thing, plug in -2, and 0 is our new guess on where this one goes. I think it's supposed to be down here. So -2 times -2 plus 0 equals 4, 4 equals 4. So they both work out. So yeah, it's supposed to be at -2, 0.